Hi students, welcome back. Let's continue with the classification of routing protocols for ad hoc networks. Okay, so we are discussing the first stage, that is based on routing information update mechanisms. So in that I explained about the 1A, that is a table driven, which is a proactive protocol. The examples for that is DSDV, WRP, I already explained. Now let's see the second one, that is 1B, on demand or reactive routing protocols. So you call on demand as a reactive routing protocols. So in this I'll just take the two examples, DSR and AODV. So now let's see what is this on demand reactive routing protocols. So these protocols finds path to destination only when needed to transmit a packet. We are saying it is on demand. On demand means whenever you need it, then only you can use it. Otherwise you don't use it. Okay, this is on demand and it should be a reactive protocol. So whenever you're required, it is just reacting. So these protocols find paths. So it only finds the paths to destination only when needed to transmit the packet. So we considered the different examples of on-demand or reactive routing protocols is dynamic source routing protocol, that is the DSR, dynamic source routing protocol, ad hoc on-demand distance vector routing protocol, AODV, and the location aided routing, associative based routing, signal stability based adaptive routing protocols. So there are still so many on-demand routing protocols are there. So in the whenever they ask the questions, try to explain minimum 2 routing protocols, means based on the marks they are providing. Okay, so let's see the first one, that is dynamic source routing protocol, which is an on-demand. This is a source-based routing protocol. So this is an on-demand routing protocol. The name itself, it is saying this is a dynamic source routing protocol. Means everything is based on the source. We are just focusing from source and we have to reach the destination. So this is a source-based routing protocol. On-demand protocol periodically exchange the so-called beacon packets. Actually, there is a difference between on-demand and the dynamic source. So what is the main difference? So if you take on-demand protocol, the on-demand protocol periodically exchange the so-called like hello packets, means I say hello to you and you're just replying hello to me. So just we are communicate each other by using some beacon packets. So whenever it requires on demand, whenever the then path is established, by say first they start with hello conversation. The hello packets are used to inform neighbors about existence of the node. So what these hello packets, that is the beacon packets, will do? It is used to inform neighbors about existence of the node. So I'm just informing to my neighbor because of existing of mine. I'm there and the next another node is coming. Okay, just informing the source and the destination, everything information is informing to the neighboring nodes. So that is a hello packet. And what about the DSR? The DSR does not use the hello packets. It does not use hello packets. Then what it does? Let's see. The basic approach of this protocol is as follows. So what it is doing, just let's see. It is not using the hello packets. Then what it is doing? During the root contraction, the dynamic source routing protocol floods the root request packets in the network. So it continuously flooding the information to all the nodes in the network, not the neighboring nodes. Okay, it's not just sending the neighboring hello packets to the neighboring nodes. It's just during the root contraction, the DSR floods the root request packet. It is asking the root request to in the network. To all the nodes, it is just asking the root request. And then what it is doing? The intermediate nodes forward root request if it is not redundant. Suppose it is not a redundant nodes, then means already visited node. If it is not already visited node, then that intermediate node forward a root request. If it is already means it is not if it is a redundant node, then it doesn't send the root request packet. So if it is not redundant only, the intermediate node forward root request means I want to go to the destination. So this is the path, and means the source here and the destination is here. Based on the shortest distance, I need to reach the destination. So that is a route requesting the nodes. The destination node replies with route reply. So whenever that destination node receives the request from all the neighboring nodes, is just reply with route reply. The destination is replying with route reply. Like how, means by selecting the shortest path, and just after visiting, after checking all the paths that are coming from the data. So after checking the paths, the destination is going to select the shortest distance path and reply to the source the route reply in the form of route reply. The route reply packet contains the path traversed by route request packet. So the receiver responds only if this is a first route request. So here the receiver, means it's whatever the node that is participating in the network, it will respond the first route request when if it is not duplicate, means already not visited, means then it respond to the first route request. Now let's see. The DSR protocol, the dynamic source routing protocol, uses a sequence number. So here we are using the sequence number, the first, second, third, like that. The route request packet carries the path traversed and the sequence number. So whatever the route request that is coming from the source, it carries the path traverse and the sequence number along with the sequence number. The sequence numbers are used to prevent the loop information and nodes check it. So why we are using the sequence number? To prevent the loop information and nodes check it. Means to avoid the redundant data, we are using the sequence number. The DSR also uses a route cache in each node. So whatever the node that is participating in the network, so whenever the DSR visits that node, it stores the information in the cache. So if node has a route in the cache, this route is used. Okay, so this is a basic introduction of this, means how the DSR routing protocol will involve in the network. Let's take an example. Okay, so let's take, this is a source and these are the remaining nodes. Let's take A, C, B, J and E, F, G, this I, let's take H, and let's take D. Okay, these are the nodes that are participating in the network. So here the source is there and we need to reach the destination. So first what it is initially do, the initially does not know the route to D. So then what it does, it can be divided into two phases. Actually the routing in DSR is done in two phases. What are the two phases? The two phases are, one is route discovery. So one is a route discovery and another is the route maintenance. Route maintenance. So first the source is replying with the two phases. One is the route discovery and another is the route maintenance. So first what it does? So first it has to discover the route. In the first phase, it has to discover the route. How it is going to discover the route? So here the node discovering route, when it's needed, then only it is participative. That's why we call it as an on-demand routing protocols. So first the source is asking about the route to D. The source is asking about the route to D by sending the request packet to neighboring. So it is sending the request packet to the neighboring. So the neighboring nodes of S is A, B, C. So it is sending the route request packet. Route request packet to all the neighboring nodes. So then the S broadcast, it is broadcasting, not unicasting. It is broadcasting the route request packet which contains the, so whatever the route request message that is sending to the neighboring nodes, this S is broadcasting in terms of route request packet. So what this route request packet consisting of? This route request packet consisting of a unique ID. Let us take a 2. The source ID is the 2. The ID from where it is coming, the unique ID Okay, let me write the point. It requires the unique ID, and a list of nodes, initially empty, a list of nodes. Actually, starting it is the list of nodes is empty. Whenever it is passing from one node to another node, the list will be filled. Next, the source from where it is coming and the destination node. So this is the root request packet consisting of. The S is sending the information to the neighboring nodes with the help of root request packet. The root request packet contains unique ID, a list of nodes, and the source destination. Okay, so the root discovery here means the root request. First it is identifying the root request and then the root reply. So whenever it reaches the destination, it sends the reply. Okay, so here the root reply send information as from E to A through. So let me explain you with the example here, and let me tell you this root maintenance also. Afterwards, I'll explain with this. I'm taking this example and I'll explain how the root is establishing. The root maintenance. So in the root maintenance, we are having the route cache. If you want to maintain the route of from one node to another node, a cache has to be maintained. So the cache is used to store the path, used to transmit the data. Suppose if any node breaks, let us take if any node breaks in the network, the root error message broadcast to all neighboring nodes. Suppose this node has break. So whenever this node breaks, it broadcasts the message to all the neighboring nodes. Okay, the node has break with infinity. Okay, the node has break, so send the error message, root error message to all the neighboring nodes. So it is sending the to all the neighboring nodes with root error message. Okay, so this is about the root maintenance. The root maintenance is holding the root cache. Why it is holding the root cache? Because of if any link has broke, means the path breaks in the network, the root error message will be broadcast to all neighboring nodes. Okay, so let's take the example for this. So I'm just taking the same example, whatever I have just shown you. Let's take another example, or A, B, C. I'm just taking a simple example, D, E. Okay, and here this is our source and this is our destination. So what this source is sending, the source has to send the root request packet. First we are discovering the root request, discovery we have to do. So we have to know the root request and the root reply also. So the source is sending the root request packets to the neighboring nodes. So in what way? The source is having the unique ID, and from starts the source and the destination to where it has to be reached. So here the source is nothing but A and the destination is nothing but E. So A has to reach E. Okay, so first it is sending to all the neighboring nodes regarding the information. So now this B consisting of the packet of unique ID from where it is getting to where it has to reach and the list in the cache. Okay, means it is visited B, so you have to place here. And the C is also consisting of the information like it reaches a packet from A like to source, destination and the visited. So up to here it is over. Next it is coming to this. The B is broadcasting to this message to all the neighboring nodes. So here only the neighboring node of B is D. So A is already visited. So still the remaining is the D. So when it reaches the D, it consisting of the unique ID. It sends the packet in the form of unique ID, source, destination, and it is coming from the path B to D. Okay. So now here, from here to here. So what are the neighboring nodes of D? The D has to broadcast the message to all the neighboring nodes. So B is already visited. So you don't take the redundant data. So B is already visited. Now let's take the D. Okay, C. So D sends the packet to C in the form of 2 unique ID, A source node, E destination node, from where it is coming, B, D and to C. Okay. So now the neighboring nodes are D and E. So D is already visited. Okay. The D is already visited. So we are coming from this path. If you take this path, we are coming from this path. The information is the packet consisting of information like this. So unique ID, source, destination. It is coming from B to D to C to E. Okay. Suppose if the data is coming like this. Okay. So it consisting of the packet information to unique ID, source, destination, from C to E, simply C to E, means it is following this path. Now the destination is going to check which route has to be selected, this route or this route. So then what this destination will select? The destination is always think about the shortest path. So the shortest path is selected and it sends the reply. So which path it will be selected? So obviously it selects this path. This path will be selected and this will be discarded. Okay. So this is about the DSR, the reactive routing protocols. Thank you.